Nampak ke?
Ya, nampak, nampak.
Okay. Today I will continue for the part of question 6.61 6.61, that is about the vapor, about the overhead product from the N-butane and N-pentane. Okay, as you can see from here, this is the feed. Then it will enter the, supposedly, if based on the question, the butane and the butane and the butane and the pentane supposedly going inside the feed in the reactor. And then based on the question, 96% of mole of butane will going to the overhead product, and the and the excessive one of 0.04% will be here at the reflux. For the question A is, our job is to find the dew point using the root law formula. Here is the dew point for the pressure vapor of root law being used. So 1 over the number of mole of A. A, it can be used for Y mole composition of A over the pressure vapor of A, relation with the temperature, plus with the mole fraction of B over with the pressure vapor relation with the temperature from the question given. Okay, to find this, for our purposes right now is to find this value by using this formula from the, if you can find this formula on the e-journal book, the Antoine equation constant from table B4. Here is the here is the equation being used to find the pressure vapor. So to find this pressure vapor, lastly, if you already find the for the component for A, B, and C, and then this is the temperature. After you calculate all this, and then you shift log the answer, and then you get the pressure vapor for P. So the unit for pressure vapor is in milligram Hg, millimeter of Hg. The temperature is must be in degree Celsius. So this is my my calculation using the Antoine equation constant. So this is how looks like the formula formula calculation use. So the temperature based on the based on the question, the temperature of the cooling fluid limits the condenser temperature is at 40 degree. So this is our temperature, 40 degrees Celsius. So from here is the A. Here is the B. For B. Here is the temperature from here, plus with C value. For now we find for the butane. Then after that we already calculate it. Then we shift lock the answer, and we can get the pressure vapor of C4H10. Next we find this for the pentane one. Still using the same formula. Using the same formula, and then lastly we will get the answer for pressure vapor of C5H2 pentane for the pentane. After it's done, next we go back using the dew point pressure before this. So our dew point pressure is this one. This is the general formula for the dew point pressure. Here our one constant one. Here is our molar composition for C4H10, and here is for our molar composition of pentane. And this is the pressure vapor that we already found from using the table before the Antoine equations constant here. Okay. Now we can sub in the value here. This is 0.96. I'm using the 0.96 based on the question and based on the additional info from the question. This is the residue left from the product.
Itu yang remaining one lah.
Yeah, remaining. So 1 minus
Okay.
0.96 lah. Yes. This is the pressure vapor that we already found for the C4H10 and the C5H10. Then we just directly calculate it, and then we can get the pressure minimum, the pressure minimum for the condenser here at as a partial condenser. Next, we using the bubble point. This bubble point, the general formula for the bubble point is the summation. The formula for the bubble point is the total up of the pressure that we got from the C4H10 and C5H12. So here is the mole composition multiply with the pressure vapor, which with relation of temperature of 40 degree. Same also this the mole composition of C5H12 times with the pressure vapor of C5H12. So here we directly multiply of the 0.96 multiply with the one we already found it. Just directly multiply and then plus. Then we can get the answer for the pressure minimum at which the operation operate as the total condenser. So that's how the calculation been used. So everyone understand ke?
Yang pentane tu temperature dia sama dengan butane kah?
Yes, sebab kalau ikut soalan dia sebab dia limit temperature dia 40 degree Celsius.
Oh.
Kalau kamu tengok temperature dia, kalau dia tukar temperature baru kamu tukar dia punya temperature lagi. Dia ikut limited temperature for condenser.
Okay, faham.
Yang Sonia dengan Rosnah faham tak?
Faham.
Okay, that's all for my part. Thank you for next part.
nanti? Boleh dengar kah?
Boleh, boleh.
Boleh, boleh.
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 For question B, suppose the condenser operates as a total condenser at 40 degrees Celsius. The production rate of overhead product is 75 kmol per hour, and the mole ratio of reflux to overhead product is 1.5 to 1. Calculate the molar flow rates and compositions of the reflux stream and the vapor feed to the condenser. So by using the mole ratio reflux to overhead production, we find the molar flow rate of the molar flow rate at the reflux stream, which is denoted as N2, and one is the production rate of overhead, which is 75 kmol per hour. So molar flow rate at reflux over molar flow rate at the overhead equal to 1.5 over 1, which is the ratio. So we get the molar flow rate at the reflux stream is 112.5 kmol per hour. And then we need to find the molar flow rate at the feed stream in order to find the composition at the feed stream and the reflux stream. So this is how we get the total molar flow rate at the feed stream. The total molar flow rate at the overhead stream, we plus with the molar flow rate at the reflux stream, and we get the molar flow rate at the feed stream, which is 75 kmol per hour plus 112.5 kmol per hour, and we get the molar flow rate at the feed stream is 187.5 kmol per hour. Since the feed and product stream composition are the same, so the molar composition of butane is equal to the molar composition the molar composition at the feed stream equal to molar composition at the reflux stream. So both molar composition of butane and pentane equal to molar composition at the reflux stream. So the molar composition of butane is 0.96 and for pentane 0.4 mole pentane per hour. Okay. Do you understand me?
Yes.
Boleh lah.
Yes.
Jadi feed dengan produk tu memang sama lah.
Yes. Kalau dia non-reactive, then the total product the total molar flow rate at the product stream will equal to the feed stream at the feed stream.
Okay.
That's all from me.
Faham.
Can you guys see it?
Yes.
Yes.
Okay. For C, suppose now that a partial condenser is used with the reflux and overhead product in equilibrium at 40 degrees Celsius, and the overhead product flow rate and reflux to overhead product ratio, having the values given in part B. Calculate the operating pressure of the condenser and the compositions of the reflux and vapor feed to the condenser. Okay. So we are given the molar flow rate for vapor feed, the overhead product, and for the reflux. And all of this value can be we get this value from question A and B. Okay. To find the composition of X2, we need to carry out simultaneous equation. So 0.69p equals to X2, molar composition of X2, and multiply by 2830.70. And we got this from Armin's part. And then we use the composition of X2 as the, what we call it, as the unknown. Okay. And then that's the first equation. And then the second equation for pentane, 0.04p equals to, in bracket, 1 minus X2. This is because the total summation of the molar composition equals to 1. So we just need to use like one unknown. So sebab we want to find X2, right? And then times by 867.25. And then this value, we can get it from A section. And then we need to sub the equation 1 into 2. So this is the steps. And finally, we got the pressure, which is 2595.64 milligram mercury. Then, as we got like the pressure, from the pressure, we can find the molar composition. So when P is, okay, so this is the step. And molar composition of butane, I guess it's pentane. Molar composition of this one, the answer is 0.8803 mole per butane mole. Then when we need to find the initial molar composition for the vapor feed, we do butane balance. This one is from the input, and this one is from the output. So from there we got this one. The initial molar composition is 0.9122 mole per butane mole. Therefore, pressure of partial condenser 2595.64 milligram mercury. Composition of reflux, we got 0.8803 mole butane mole. And the composition of feed, we got 0.9122 mole. That is all for me. Do you have any answer? Do you have any question?
Jadi yang first tu, cari X2 dulu lah. Lepas tu cari XO dia.
It's either one actually. You just need to choose one, and then you boleh apa this? You can choose either X0 or X2. So later on you can sini pun. What?
Tapi sama jawapan kan?
Ya, sama juga. Got question?
No.
Yang lain dah selontak.
No.
Rosna?
Yep.
Okay.
No.
Yang lain faham?
Faham?
Understood.
Okay. Thank you.
Okay, that's all for our discussion for week 14. I hope we can uh, maintain to understand this question for the chapter 6 later on for the
For the
upcoming,
final exam.
yeah, for the upcoming for final exam later. So good luck and do a do a better result for this mass balance program, mass balance course. So I hope I can see you guys later. So you